Bright Tuty. Every student matters.
Let us see it by an example. For example, let's first of all learn the division and find the quotient and remainder. For example, in this case, the dividend given is x cubed minus 3x square plus 5x minus 3, and I need to divide it by x square minus 2. So, the first term here, right, you have to focus on the first term here, and you need to produce this first term by using this term, right. What do I multiply in this to obtain this? Obviously x. So, if I multiply it by x, I will get x cube. So, x cube, and when I multiply minus 2 with this, I will get minus 2x. So, write it below 5x. We write like terms below the like terms, right. Then I subtract. It will get cancelled. Let us write rest of the terms as it is. 5x plus 2x as 7x minus 3. Okay. Now, how do I make this term using this term? By multiplying it by minus 3. So, multiply minus 3x square, minus 3 into minus 2 will give me plus 6. So, I write it below the constant term. Now, subtract. This will get cancelled. 7x will come here and minus 9. Now, you notice that we cannot divide it further. Why? Because the degree now is lesser than this, right. I cannot produce this term by multiplying any polynomial with this, right. All right. So, this is the remainder here. So, now for this question, quotient is x minus 3, this one, and remainder is 7x minus 9. Okay. So, where do we stop dividing? When we get the remainder such that the degree is lesser than the divisor, right. So, let us look at this question. We need to divide a biquadratic by a quadratic. So, let us write x raised to power 4, 3x squared plus 4x plus 5, and we have to divide it by x square plus 1 minus x. Okay. First thing that we do is we write it in standard form. So, you should write this x here and 1 here. We write it in descending or ascending powers of variable. So, let us write it in descending powers. So, we can write it as x square minus x plus 1. Okay. So, now to produce this term from this, I need to multiply by x square. I will get x raised to power 4 minus x cubed. There is no x cubed term in the dividend. So, I write it here plus x square, right. So, now subtract, right. This term gets cancelled and x square term also gets cancelled here. No, it will get added, right, because this is a minus sign, this is a minus sign. So, minus 2x square, right. So, it will not get cancelled, it will get added to it. So, x cube minus 2x square plus 4x plus 5 is what I get here. Now, to obtain this one, I multiply it by x plus x, x cubed minus x square. So, I write it below this plus x. So, then I subtract, right, x cube get cancelled, minus 2x square plus x square give me minus x square plus 3x plus 5. Now, the degree here is same as this. So, we can divide it further. X square, how will I produce minus x square? By multiplying it by minus 1, right. When I multiply it by minus 1, it will give me minus x square plus x minus 1. Now, if I subtract, it will give me plus minus plus. So, it will get cancelled. 3x minus x is 2x, 5 plus 1 is 6, right. So, this is now my remainder. This is remainder Why this is the remainder? Because the degree now is lesser than the divisor. So we stop the division at this place, right? And this is my quotient. So quotient required is x square plus x minus 1, and remainder is 2x plus 6, right? So we will do these questions by simple division of polynomials. This question is also pretty simple. We can do it like the previous questions. 5x plus 6. Now to write it in standard form, let me write it as x square plus 2. There was a negative sign here, so I placed it here, plus 2, right? I have not changed this expression, I have just flipped the term, right? Keeping the expression intact. So now to produce this first term by this term, I have to multiply it by minus x square. So it will give me x raised to power 4 minus 2x square. Okay. Now subtract. This term gets cancelled. This is the aim of this division, right? To get the first term cancelled and then see how the rest of the terms behave. Okay. So now the subtraction. There is no x square term here. So I will write 2x square. This minus 5x will come as it is, plus 6, right? Now focus on this term and this term. What do I multiply this term with to get this one? Minus 2, right? So minus minus plus 2x square, right? Minus 2 when multiplied by this will give me minus 4. So I write it below 6. Now the subtraction. This term gets cancelled. So it will give me minus 5x plus 10, right? So this is my remainder, right? Because I cannot divide it further. I cannot multiply this part with any whole power of x to get this, right? So I stop at this point. So my quotient here is minus x square minus 2, and the remainder is equal to minus 5x plus 10. Okay. Now we need to check whether the first polynomial is a factor of second polynomial by dividing the second polynomial by first polynomial. What did we discuss about for a polynomial to be a factor of another polynomial? It has to divide it completely, leaving no remainder, right? The remainder in this case will be 0. So if I divide this polynomial by this polynomial and get the remainder 0, then I can say with certainty that this is a factor, otherwise not, right? So let's see by dividing 2t raised to power 4, 3t cubed minus 2t square minus 90 minus 12, right, by t square minus 3. Okay. So again focus on this term and this term. I multiply it by 2t square. So I will get 2t raised to power 4 minus 6t square, right? Minus 3 into 2t square will give me minus 6t square, right? So now I subtract. This will get cancelled. 3t cubed plus 4t square minus 90 as it is minus 12 as it is. So now focus on this term and this term. Plus 3t will give me 3t cubed minus 90. So write minus 90 below this, and then subtract. This will get cancelled and this will get also cancelled. So I will be left with 4t square minus 12. Now you can easily see that if I multiply it by 4, it will give me 4t square minus 12, right? And the remainder is 0 here. Remainder is 0. Hence I can say t square minus 3 is a factor of this polynomial, right? So this is the way we ascertain whether a polynomial is a factor of another polynomial or not, by simply dividing it and observing whether the remainder is 0 or not. So in this case, yes, it was a factor. Now let's look at this case. Here I have got a biquadratic again, which is 3x raised to power 4, 5x cubed, 7x square, 2x plus 2, and I need to divide it by x square plus 3x plus 1, right. The division will work in the same way. I have to concentrate on these two terms. I multiply it by 3x square to get 3x raised to power 4. Now 3x square multiplied by this will give me 9x cubed, and multiplying by this it will give me 3x square, right. Now I subtract minus minus minus, and this will get cancelled. It will leave me with minus 4x cubed, minus 7 minus 3 will give me minus 10x square plus 2x plus 2 as it is, right. Now if I multiply this one by minus 4x, it will give me minus 4x cubed, it will give me minus 12x square, and this multiplication will give me minus 4x, right. So our entire purpose is to cancel the first term. Now this first term gets cancelled, plus 12x square minus 10x square will give me 2x square plus 6x plus 2, right. Now you can see that if I multiply it by 2, it will give me 2x square plus 6x plus 2, right, which is the same expression. So it get cancelled and give me 0 as my remainder. Now if 0 is a remainder, then I can say that the divisor is a factor of dividend. So yes, x square plus 3x plus 1 is a factor of this polynomial. All right. So this is another case. This question I leave it to you for practice, right. What you will do is you will write the dividend here, right, divisor here, then focus on first terms, right. Your entire focus should be to create this term from this term. So I multiply it by x square. Now rest of the terms you can write below the like terms and repeat the process until and unless we get a remainder. Either it should be 0, then it will be a factor. Otherwise, if the remainder is not 0, then we can say that this is not a factor, right. So do it yourself. Okay. Now let's look at this question. Find all other zeros of this biquadratic. This is a biquadratic. So how many zeros will a biquadratic have? Obviously 4, right. What is a biquadratic? I told you that biquadratic looks like this, right, when in a factorized form. So it will have maximum 4 zeros, right, and we are given with 2 zeros, right. So let's say I am given with these two factors. These two factors are given already. So I need to find these two factors. Okay. So I can club these two to make a quadratic, right, because this is given, and this quadratic is a factor of this biquadratic, right. So how do I obtain other factor? By dividing this biquadratic by this quadratic, right. So what is the quadratic here? It is of the form a plus b into a minus b. So I can write it as a square minus b square. So this one is like x square minus, what is the square of root of 5 by 3? It is simply 5 by 3, right. So this is the quadratic which is given as a factor of this. Okay. So I can also write it as 3x square minus 5 will also be a factor, right. If I multiply and divide it by 3, what I can do is I can take 1 by 3 as common, right. It will still not make any difference. It will still be a factor of this biquadratic. Now what is left is I simply divide this biquadratic by this quadratic. So what is the biquadratic here? 3x raised to power 4 plus 6x cubed minus 2x square minus 10x minus 5, right? I divide it by 3x square minus 5, right? So what will I get as a quotient? I will get a quadratic, right? What should be the remainder? Remainder should be 0, so that we can get other factors also, because this is a factor here, so remainder obviously will be 0. Now let's create this term from this term. I will have to multiply it by x square, 3x raised to power 4 minus 5x square, right? And then subtract. This one will get cancelled. 6x cubed as it is plus 5x square minus 2x square will give me plus 3x square minus 10x minus 5. Okay. Now this term from this term will get created by multiplying by plus 2x. So it will give me 6x cubed. And the other term that I get here is minus 10x. So minus 10x I write here. Now subtract. This will get cancelled, this will get cancelled. So I am left with 3x square minus 5 at this step, right? 3x square minus 5, which is same as this. So I just multiply by 1. 3x square minus 5. So this entire term vanishes and gives me 0 as remainder. So this is my other factor, right? So the biquadratic in question can be written as 3x square minus 5 into x square plus 2x plus 1. If some student is confused that why did I write 3x square minus 5 and not x square minus 5 by 3, we are here to calculate the zeros, remaining zeros, right? So if I write 1 by 3 here, it won't make any difference to the zeros, right? This is, let's say, the polynomial that is required. This will give me my zeros that are given, minus root 5 by 3 and root 5 by 3, and this one will give me rest of the zeros. This won't make any difference to the zeros. So let's calculate rest of the zeros. As is obviously seen that this is nothing but x plus 1 whole squared. So the factors of this biquadratic can be written like this: x minus root of 5 by 3, x plus root of 5 by 3. These two are already given, and this I can write it as x plus 1, x plus 1. Okay. So the remaining zeros, so the remaining or required zeros are minus 1 comma minus 1, because these two brackets will give me same zeros, minus 1 and minus 1. Okay. All right. So let's look at this one. On dividing this polynomial, this is a cubic, x cube minus 3x square plus x plus 2 by gx. Let us say I divide it by gx. Quotient and the remainder were these. Okay. Find gx. So I have divided it by gx. So what was the division algorithm? Dividend is equal to divisor gx into quotient. What is quotient? X minus 2 plus remainder. So plus remainder is minus 2x plus 4, right? So I can rub this plus sign here. So what I have done is px equal to gx into qx, that is quotient, plus remainder. So remainder is minus 2x plus 4. Now I am here to find gx, right? So gx is what we need to find out. So let's take rest of the terms to the left hand side. So gx into x minus 2 will be equal to x cubed minus 3x square plus x plus 2. When I take minus 2x there, it will give me plus 2x plus 4 will become minus 4, right? I have just taken it on this side. So x cube minus 3x square plus 2x plus x will give me plus 3x, 2 minus 4 will give me minus 2. Now gx into something x minus 2 is equal to this. So what will be gx? Gx will obviously be when I divide x cube minus 3x square plus 3x minus 2 by x minus 2, right? What I get here will be my gx, right? So let's find out. When I need to produce this term by this term, so I multiply by x square. X cube minus 2x square, right? Then subtract, this get cancelled, minus x square plus 3x minus 2, right? How do I produce minus x square? By multiplying it by minus x. So when I multiply it by minus x, it will give me minus x square plus 2x, right? Now subtract, this gets cancelled, 3x minus 2x will give me x minus 2. So x minus 2, x minus 2. So multiply by 1. So x minus 2 gets cancelled completely, right? So the other factor is x square minus x plus 1, which is g of x, right? How do I obtain this one? By multiplying x minus 2 into this. So what is this? This is gx, right? So the required g of x is equal to x square minus x plus 1. Okay? Give examples of polynomials px, gx, qx and rx which satisfy the division algorithm, and degree of px is equal to degree of qx. So I need to find px, gx, qx and rx such that degree of px is equal to degree of qx. What is given here is I need some px which when divided by gx will give me qx, right? So here I will get gx into qx and rx here, right? So in the first part I need degree of px, this one, and degree of quotient as same. Okay, so now if I write p of x as equal to g of x into q of x plus rx, and I need these two degrees as same. Okay, so what I will do is, let's take the polynomial px, any general polynomial, as 2x square minus 2x plus 14. Let's take it like this. And if I divide it by certain constant term, if I divide it by constant 2, okay, what will I get? I will get x square minus x plus 7. That will be my qx. So let's divide it by a constant 2. Okay, let's take gx as 2. So what will be my qx? It will be equal to x square minus x plus 7. And what will be the remainder? It will just be 0, right? So if I take 2x square minus 2x plus 14 here and divide it by 2, okay, I will get x square minus x plus 7 here, right? And remainder will be 0. Okay, so this way I got the degrees of px and qx as same, which is equal to 2, right? This is a simple manipulation. You don't have to memorize this, you can create it there and then, or you can memorize some of the expressions. You could have taken like 3x square minus 6x plus, let's say, 21, right? So you could have divided it by 3. You could have divided it by 3. So you would have got x square minus 2x plus 7 here. Degrees of px and qx again are same, and the remainder will be 0, right? So this is how we can create these expressions. Degree of qx is equal to degree of rx. Let's write the expression once again. Px equal to gx into qx plus rx, right? This was my expression. So how do I write the degree here? Let's take p of x, g of x, q of x and r of x. Let's take a general expression for p of x as x cube plus x square plus x plus 1, g of x as x square minus 1, q of x as x plus 1, and r of x as 2x plus 2. Now qx and rx here have the same degree, which is equal to 1, right? Now if you divide this expression by this one, you will get this q of x and this r of x, right? So these are very simple examples. You can memorize these or you can create there and then, but if you create there, then it will be a little difficult, right? So I would recommend that you remember these expressions. Degree of rx equal to 0, I leave it to you. Do it yourself, right? So this was about this lecture. Thank you.